In an EDM process, using RC relaxation circuit, a 12 mm diameter through hole is made in a steel plate of 50 mm thickness using a graphite tool and kerosene as dielectric. Assume discharge time to be negligible. Machining is carried out under the following conditions: resistance equal to 40 ohms, capacitance equal to 20 microfarad. Here, capacitance should be 20 farad, not microfarad. Question is wrong. Okay. Supply voltage equal to 220 volts, discharge voltage equal to 110 volts. Then first question is the time for one cycle in milliseconds is. Second question is average power input in kilowatts is. Here a 12 mm diameter through hole is made in a steel plate of 50 mm thickness by electrical discharge machining process. Okay. First question is time for one cycle. Cycle time formula is in EDM process is RC into Ln Vs supply voltage by supply voltage minus discharge voltage. Each and every value is given in the question itself. Substitute these values here. You will get 555.5 seconds as the cycle time. Convert this value into milliseconds, that is 0.55 milliseconds. To calculate the power in EDM process, formula is given as 0.5 into capacitance into discharge voltage square by cycle time. Substitute cycle time in seconds, not in milliseconds. So 555.5 seconds. Substitute this value here, and capacitance we already know. Discharge voltage also given. So you'll get 218 watts. So if you convert this value into kilowatts, that would be 0.218 kilowatts. Option C is correct.